How are we doing, guys? So this is the 2016 higher level question 1, the orthographic question. First things first, I'd just like to have a look through the question, just see which direction the end view is going to be projected in order to place my elevations and stuff like that. So draw the elevation direction of our way, that's fine. Project a plan, lovely. And then so our end view is in direction of arrow B. So because it's being shot into the right hand side, our end view will actually be on the left hand side of our elevation. So our elevation should be placed in the top right corner of our page. The overall height of the object is 110, so we must come down at least 110, come down a bit more, and our end view then is going to be a width of 67 and 40, so 107. Yeah, so we're going to go ahead and start, and our true shape surface is S here, so we'll get to that near the end. So you don't have to wait for me, you can skip on. I'm going to go through every part of this question. Okay, so first things first, we're going to do our elevation. Alright, so we're told the overall height is 110. So what I'd like to do is, so there's 110 to the edge of the page. I'd like to come down about 100. It is 110, isn't it? Yeah, so I'll come down about 130, if not more. Right, and I like to just draw a nice horizontal line across the page. So both our end view and our elevation are going to be placed on that horizontal line. So the overall width of our elevation, you can see at the top of the question, on the top of the object, is 240. So some of your set squares might not actually have 240. You can see mine doesn't, it only goes as far as 230. So I'll just measure in, so I pretend I'll say that's 240. Is that right? Is there a scale? No, 240, yeah, it's a pretty wide object. Okay, so if I came in 240 to there, the end view has an overall width of 107, we're saying. Yeah, so that gives me plenty of room there. Right, sugar. So that's my, let's say that's the bottom left corner of the elevation. So there's 230, and I'll just add 10 to that. Okay, so that's your 240. So it's a pretty wide elevation. So I'm just going to shoot up two horizontal lines, or two vertical lines here, sorry. So that's the overall width of my elevation, and the height is 110. So anything I'm doing in red is light with a sharp pencil. So there's 110, and I'll draw a horizontal line there, and I'll actually bring that the whole way across the page as well, because that's going to come across onto my end view when it's over here. Right. Okay, so my elevation is going to sit in here somewhere inside that space. I'm going to go ahead and start putting in a couple of dimensions. So, alright, if it's an overall width of 240, I'm going to find the center just to help me out. I'm going to work from the center out. So half 240 is 12, simple enough. So there's the dead center and a horizontal line again, or vertical line, sorry. Right, so I want to find where these left and right hand side pop up. So I'm going to go to the very top, and I'm going to go, I'm not actually, I'm going to work 67 into it. Perfect. So that gets us into the center, and then there's a radius of 15 popping out either side of that. So I'm going to measure out 15 from that. Right, and that's the top of the elevation. So we can go ahead and draw those two slanted sides, because the radius 15 meets the bottom left and the bottom right. Lovely. Okay. Now, have a look here at the front. So see where it's like a cylinder and it's cutting into our object. We will not be able to draw that without finding our end view, locating points in our plan by 60/30 and the semicircle on top. So we will not be able to draw that curve just yet. That will be done after the end view and the plan is drawn. So there's not much else we can do at the top for elevation, so I'm going to go ahead and just do this in front bit at the front. So this is what contains our true surface. We want to try a true shape of surface S. So in 67 has an overall width of 106. So if I just come 53 out from either side, I should get us 51, 52, 53. There you go. It's 106. Lovely. Height of, there's a 12 and then there's an 18 on top of that. So that's 60. Oh. Alright, so it's in 22 from either of those. Okay, so we've just found our surface S. Sorry about hitting that. Right, so there's our surface S there. Right, so it's actually going away from us. Right, so I'm going to put in the front bit in heavy because I'm confident enough with that. Okay, so that's the front part done, and I'm just going to do the bottom in a nice horizontal. I can do that in heavy. Right, and what else can I do? Top, I can do the top horizontal line as well. Okay, and the left and right side. Okay, so we're going to go ahead and do the plan now. So I'm going to leave a gap of 20 mil between the plan and the elevation. Right, and a horizontal line just to start me off. Just there, and what I'll do is I'll bring all these distances down. Bring them all vertically down. So try to be efficient here and work work along. Don't start here and work your way across because you're going over yourself. Try work away from the last line you just drew. So that's the very top there. Show you where that came from. Right. So there we have it. So I brought most of my lines down. Right, for the plan, so I'm just going to do the main body first before that bit jutting out. So it has an overall, it juts back down 67. Alright, so that's your 67. And so the bit at the top then, so it steps down 15 mil. Right, from the center you're coming out. Right, how are we going to manage this? Right, so from here, so there's your 15, we brought them down already. Did we? Yeah, that worked out well. They're vertically above that. Yeah, lovely. So that's it's an arc. So they should match up. Why are they not 15 now? Okay, so you see I'm a little bit off there. That's due to the thickness of the fine liners. That's why I always get you to try to use a sharp pencil. Well, you should be using a pencil as sharp as possible. You can be far more accurate. See, I'm off there by about a mil. That's due to the thickness of the fine liner. Okay. That comes in then. Okay, so we want to find where this, so it has a radius of 30, this semicircle here. So I'm going to put a radius of 30 on my compass from the center, and I'm just going to pop out here. So, right, 30. So there we go. So radius 30 in your compass for that semicircle. And just grab your arc. Right. So that's an important semicircle because we're going to have to 60-30 that in order to find that freehand curve in the elevation. Okay. So that's the top done. I'll just show you in heavy then because I'm pretty confident that's finished almost. Okay, and there's also a little section, a little rectangle in there in the steps, so 40. That has a width of 15. Okay, I'm not going to put that in heavy just yet because I'll only end up confusing myself. Do you know what, I would actually consider it separated from the 30-60 I'm going down. Right. Okay, so the right, so we can come out here as well horizontally to the end. And then that's, yeah, that arc there. So be careful where you put your center here for swinging this arc. So just note in the question where the center of it is. Okay, there you have it. And we'll go ahead and do the front bit as well over here. So it juts out 40 from the very front. So I step down 40 along this line. Okay. Right, the very front part is there, and it goes back. So there's the very front part, lovely, and that goes back then to there, and there's S as well. So what that line I've just drawn there represents is S as an edge. Alright, so that is S as an edge. That's a very important line, and you'll see why later on. Okay, that's fine, and then that steps back in. We don't actually know how far to come back in with this line because you don't actually know where that hits the slant of the object itself, so we're going to have to go ahead and draw our end view. Okay, yeah, I'll just do the plan as much as I can in heavy just to help us out and try to visualize things. Alright, so this edge here is very important. That represents surface S as an edge. Right, okay, moving on to our end view. Okay, so from the bottom left of our elevation, off at 45 degrees. I'd much rather do a 45 degree line like that rather than coming up at 45 degrees, because what you can find is people sometimes forget to bring everything over to this YY line, that they actually bring points from here. For instance, they could bring that point up at 45 degrees, and of course that's not correct. Alright, so I like to have a line of 45 degrees, bring everything over to it, and just work from that. So I'm going to bring all my lines horizontally across onto that 45 degree line. Okay, so that's that little rectangle bit out in the front of the, that's very important, and then the very front of it. Okay, so what I'm going to do first, I'm going to bring the overall width of the main body. So it should be 67 anyway. Okay. So you can even actually see in the question, so I'll show you here. So what we're trying to draw, what I'm trying to draw first is this. Alright, so that's exactly what I'm trying to draw first, because when we find that slanted edge there, so that one I just drew, that'll help us locate points along this, and it'll also help us find that point there, because that point at the moment is unknown to us, and that'll help us finish off our plan. I've just noticed I haven't completed, or you'll notice as well, I haven't completed this rectangle because I need to find this edge and measure 10 down along that both ways. Okay, so it was impossible at the moment, or so far, to measure that 10 because it's actually on that slanted edge. Right, so the elevation or the end view will actually allow us to find that. So what we'll need for that is this little part. Alright, so try break down the question into its basic objects as well at the same time. Okay, so I'm going to go ahead and try to finish it off. So that slanted edge I was just on about, it's this one here. Okay, so that's a very important line for us. That's going to help us find a lot later on in the question. What else can we do? Okay. Go ahead and draw as much as I can. I'm going to draw this in heavy because this will be seen. Okay, so just looking, I'll go ahead and I'm going to try to draw the freehand curve here. You know what? I'll try to finish the actual end first. So one part of it as well. And that is a height. It's also important to bring your heights across from your elevation. It just speeds things up, helps you a lot, move things a lot quicker. Right, so what we've actually found is that important point I was telling you about, of how far back in we come here. So I'm going to bring that down straight away. Bring that down to our plan. And there you have it. Alright, so we can actually finish that little bit of our plan. So that point there is very important. Bring it down. And that's how far back in we go. Okay, so that's the front part of our plan finished. So I'm going to go ahead and I'm going to draw the front bit of our semicircle, the half of the cylinder thing that's jutting out. So here's the very front of it. I have it brought across already, and I'm just going to bring it up. Okay, and where it hits that slanted edge is also very important for our elevation, so I'm just going to bring that across straight away. So that point there represents this point here, so that's how far down that freehand curve comes. So what we're going to have to do is try locate a couple of more points to help us finish that freehand curve. So we're going to go ahead and give that a go. So first I just want to bring this semicircle up to the top. Right, so our freehand curve is in there somewhere. I just want to find a couple more points to help us finish it off. So we're going to 60-30 our semicircle on our plan. And I'll just number them just to help me out. So 1, 2, 3 we found already, which is already there. 4 and 5. Just bring them vertically up straight away. 1, 2, 3 is up there. 4 and then 5. And we have the top ring. You notice we've actually, look, there you go. 1 is actually on that front bit of the rectangle already, and 5 is there as well, so that helps us. There's one less line we have to draw. So 1 and 5 and 4 and 2. So this is 2 and 4 on that line, and this is 1 and 5. So where they hit that slant, so where they hit that line, so there is 1 and 5 and 2 and 4 right here, 2 and 4, and you can bring them horizontally across when they hit that slanted line. Now we just need to match them up. So go with 1 first. So 1 came up to here. There's 1. 2, 4. Because 3 is found already, so that's 4 there. And then 5 is there. And we know that the semicircle goes all the way up to the top, which is here. Alright, so there's your, you can actually see the curve already. So you know what, go ahead and draw that. So try and make it as curve-like as possible. Do not just join the dots. Try to give it that curve effect as much as possible. Okay, so I'm pretty happy with that. So that's the freehand curve drawn. Okay, to finish off our end view, so a bit jutting out at the front. So, yeah, that's that slanted edge there. Right, so this is the slanted edge I was on about. We can measure the 10 down along. Right, so measure up 10 and measure back down 10 from the on the line. Now, do not measure horizontally across. I want you to measure exactly on the line. Right, so that's finding that little rectangle for us. Bring them straight down and locate them then in your plan. And yeah, we can draw that. So you'll see exactly what I was on about now. Okay, so that's that little rectangle part there. What else can we do? What you've actually noticed as well is that surface S there. So I'll go ahead and finish that actually for us. So that's horizontally out. You'll see that the whole image. So there is a bit of how far down we're not down we are. 8 minutes. So there's a bit of hidden detail that they're missing is the bit at the very top, this rectangle here. So that actually sits down 8 mil. So I'm just going to draw that here. So from the top, I'm just going to measure down 8 mil first. Draw a horizontal line across because we need that in our elevation as well. Okay. So we represent our hidden detail with dotted lines. Okay, so that's it up there, and then we need to draw it. Sorry, here it is in our end view. So that needs to be Okay. I'm nearly done. Sorry, I'm missing a horizontal line here, and a vertical. And that's surface S. This is S here. Okay. Now, so have we drawn the elevation complete? Have we the elevation completed? No, I have to draw this rectangle. So where we measured down 10 along this slanted line, bring that across. And when we measured up 10 along the line, bring that across as well. So you're trying to find this rectangle here, and so there's there. Okay, surface S. Okay, so we need to find the true shape of surface S. So there's a couple of ways of doing it. We could use our end view. We could use our elevation. I would like to. I'd like to use our end view, but I don't think we're going to have enough space here. I notice a lot of you, I reckon a lot of you might come into that problem as well. So we're going to show it in our elevation. It's the same thing. So what we're going to do is we're going to use that line there as our hinge almost, and what we're going to try to do is rotate the object around. So we need to rotate those points around, and we're just literally going to redraw surface S here. Okay, so that's really what we're doing, and I'll show you how we're going to do it. So, as I mentioned previously, we're going to use that as our hinge, and what I mean by that is basically we're just going to place our compass on it, and we're going to extend the length of the edge. Alright, so that's the edge of surface S, and just rotate it around so it's on the same horizontal line as the hinge. Okay, so that rotation there is basically containing those 2 points there that I rotated around, or those two, see those 2 arrows, and we're going to bring out this point on surface S, and when we reach that line on the hinge, that horizontal line, so what I did was I rotated. So if I was to number them for you, so let's say that's A, our letter, sorry, B, and then our hinge is C. So we'll go CC for our hinge. So there's our hinge C, and C is underneath obviously as well, so it's able to CC. Here we have A, and B is underneath it. So I'm bringing AB around, so it's on the same horizontal line and same axis as the hinge. So when it hits that line, just bring it vertically up. And we're just going to match it up then. So we're basically rotating it around. So there's AB, so there's A, and there's B. And what you can do then is just join the dots. So there's C to A, and there it is actually there. You can just go ahead and draw it. And then A to B again. And there it is there. So this here is the true shape of S. So I'll just put it in there, show you. So this, so you don't have to color it in like this. You can just show that you know how to do it, but that'll do it. And there's the true shape of S. So what we did again. So this line here, so that line there is very important. That line there is an edge view of this surface S. So what we did was basically rotated it from there, using C as our hinge, rotated it around, and then just basically flattened it down by bringing it up to our elevation. So we were given our surface S like that, sorry, it was coming towards us. Okay, and then we literally just rotate it around using C as our hinge, and then flattened it down. Okay. Yeah, so that's the true shape of surface S. I think we're pretty much finished now. I'm just going to look at the question again. So another way you could do it is if you want to rotate, you could have rotated C down here, brought it across and up, but as you can see we're running out of space, so this is just much quicker and much easier. Yeah, I'm pretty happy with everything there. That's the 2016 Junior Cert Higher Level Question 1 completed. Yeah, we were hidden detail in as well. Yeah, so thanks for listening.